The Society of Toxicology of Canada, STC, aims to celebrate the research and contributions of its members and provide insight to current and future trainees about career paths within the field of toxicology. Today, the STC is extremely excited to feature Dr. Alison Holloway. Dr. Holloway is an internationally recognized toxicologist whose research focuses on the effects of exposure to chemical insults on metabolic and reproductive health. Her research has contributed to over 150 peer-reviewed journal articles, 3 book chapters, and more than 150 abstracts and presentations at meetings. Dr. Holloway received her BSc in zoology at the University of Toronto and PhD in endocrinology at the University of Guelph. After returning to the University of Toronto to complete 2 postdoctoral fellowships in physiology, Dr. Holloway then moved to McMaster University, where she has been a professor in the Department of Obstetrics and Gynecology since 2003 and Associate Chair for Research since 2016. Remarkably, she has developed a number of collaborations with clinicians and basic scientists in industry, academia, and government, as well as traditional land users and First Nations communities to explore multidisciplinary questions related to the impact of oil sands activity on human and wildlife health. Most recently, Dr. Holloway led a knowledge translation initiative and mentored a group of high school, undergraduate, and graduate students in order to create an online portal to toxicological wildlife and environmental monitoring data from the Alberta oil sands region. The research, projects, and collaborations fostered by Dr. Holloway continuously demonstrate the importance of interdisciplinary communication across academia, government, industry, and the local community, and are a testament to her commitment in contributing to the advancement of the field of toxicology. With that, the STC would like to give a warm welcome to Dr. Alison Holloway.
So I first heard about STC when one of my colleagues, Mike Wade, had asked me to give a talk at STC a few years ago. I had a really great time at the meeting, and I really enjoyed all the discussions at the meeting and talking about new collaborations and projects that were ongoing in the Canadian ecosystem. And so after that, I decided to join as a member. So I really enjoy the in-person meetings of STC. I think that they're a great forum for trainees to present their research in a supportive and collegial environment. And so I would say that overall, it's not just one experience, it's all the experiences of getting to go and meet with all of the Canadian toxicologists in an environment that's supportive and celebrating the work of our trainees and the next generation of toxicologists in Canada. So I'm a little bit late to the party, to be honest, in toxicology. So most of my research was on early life exposures to chemicals and how those impacted metabolic health in the offspring. And it wasn't really, at the time, I didn't really consider that it was toxicology. I considered that it was like DOHAD research or fetal programming research or diabetes research or obesity research. And it wasn't until I started thinking about it in a broader scheme that I realized it is actually toxicology research, and it's a different form of toxicology. So I really like the fact that toxicology is such a broad discipline, and you don't have to be in one particular box to fit into a toxicology framework. So broadly, we have 3 main streams of investigation. So one is we're interested in the effects of different medication use during pregnancy and how those impact fetal health. In those studies, we're looking at predominantly smoking and smoking cessation products or cannabis use during pregnancy, and also looking at the effects of maternal and paternal antidepressant use and how that might affect offspring metabolic health. So the second sort of stream of projects, we're looking at the effects of environmental contaminants and how those might affect metabolic disease risk. So those are more broadly contaminants that are present in the environment and how exposure to those may be contributing to diabetes and obesity risk. The third stream of projects is our work that we're doing with a number of Indigenous communities, mostly in Alberta. We have 2 projects, one with Mi'kmaq Cree First Nation up in Fort Chipewyan, where we're looking at the effects of contaminants from oil sands extraction and how those affect reproductive health of a key indicator species. And the second more recent project is with Stoney Nakoda First Nations, where we're looking at the impact of selenium from coal extraction. We're actually focusing on women's knowledge about how selenium might be affecting the health of traditional foods and how it might be affecting reproduction in some of those traditional foods. So that project's not only a community-based project, but has some lab-based aspects where we're looking at the effects of selenium on key reproductive tissues in the lab. So that's a tough question. And I always tell my students in my undergraduate course, my toxicology undergraduate course, that sometimes it's a random conversation, sometimes it's a paper that you read, sometimes it's something that you were interested in that you heard about in a course. For me, some of my most exciting projects have started with just a casual conversation over a beer. So for example, the work that I'm doing up north in the oil sands, I had a meeting with Kelly McKittrick after he gave a seminar in Calgary. And he asked me if I was interested in looking at reproductive outcomes in mammals that have been collected in the oil sands region. So after thinking about it for a nanosecond, my answer was, of course I would be. And that started us off on a whole new direction of research in the lab. So I would say in that case, it wasn't a lot of thought. It was just having my eyes open and willingness to take the opportunity as it presented itself. So I think there's really some interesting emerging contaminants coming out. As the analytical chemistry gets better, we know a lot more about what the exposures are. So now there's a whole suite of chemicals called halogenated polycyclic aromatic compounds, which are showing up in human serum and in seafood. I think those are really interesting. I think by and large, we've been focusing mostly on reproduction, and that's in part due to the fact that a lot of the work that we're doing with the Indigenous communities in Northern Alberta, the communities are concerned about the reproductive health of the wildlife and traditional foods because that actually impacts the availability of the foods. So I think that reproduction is a more immediate concern. So I think for that reason, a lot of the work is going to, at least the stuff that we're doing with the communities, is going to focus more heavily on reproduction than metabolism. That being said, I love both aspects of the work. I just think that as the community brings concerns to us, they will be more heavily focused on reproductive outcomes than whether an animal is metabolically healthy or not. Yeah, so the Kotawan Portal is a toxicology monitoring data portal. So it is actually a collaboration with the scientists at Environment and Climate Change Canada and people in my lab, and also people who wanted to join our team to work on this project. What it does is it takes the wildlife monitoring data from the Hunter and Trapper Wildlife Monitoring Program that's run by Environment and Climate Change Canada and the Oil Sands Monitoring Program. And it takes those data points and it has put it in a website so that people who actually are on the land or people who are interested can go into this website and look at the quality of the wildlife that have been collected in the oil sands region in an interactive way. So there's ways that they can look at a specific trap line, they can look at overall quality of the wildlife that have been collected on each individual trap line on a map. What started as just a way to visualize the data became so much more. So now the portal includes a biota quality index, which is sort of simply put the health of the animals that have been trapped on different trap lines in Alberta. It also looks at the differences in land coverage over the last decade or so. And then a bunch of my team members who were not as interested in the data analysis really took off with all the creative aspects of the portal and started working on videos to explain how the sampling is done, how the measurements are done. So what we've tried to do in this portal is to make sure that the data is not a bunch of spreadsheet information where people don't understand what species was collected or what those numbers actually mean. So we've tried to not simplify, but we've tried to distill down the information about the wildlife that have been collected in the area to make sure that the data is accessible to anyone who wants to have a general overview of what the wildlife quality is in the different areas of the oil sands region, with the understanding that the data that went into generating all of these scores is available to researchers if they want to access it, and they can expand on their analysis of what's actually available. But the main goal was to make this accessible to anybody who wants the information without having to look at a whole bunch of spreadsheets with a bunch of numbers that are actually, quite frankly, meaningless to most people. So it became a really much bigger project than we originally anticipated, and it pulled on creative talents in big data, website development, video making, and so it's really a testament to all of my students' skills and different talents that they were able to pull this together in this multimedia format. So that's a tricky question because it often comes down to the work that we do with the animal models and the cell culture models. They are often not used in making clinical practice guidelines, right? So that's always the criticism you get is like, well, you showed that cannabis did X in a rat model, so how do we know what it does in human models? That being said, I kind of view this as a whole spider web, right? So we get a piece of data in a cell culture model or in an animal model, and then people start looking in the human populations to see whether or not you have a similar effect. And that taken together, it all contributes to sort of the bigger picture of what happens or what are clinical recommendations about nicotine exposure during pregnancy or cannabis use during pregnancy. So I don't think that my work will be a direct, like I found X, and so now policy will change. But I do think it contributes to the larger conversation and the larger body of evidence that contributes to developing those policies and clinical practice guidelines. I think that's really difficult to predict simply because toxicology is so broad, right? Like in the field of toxicology, there's really something for everybody. There's working with alternative models so that are not animal-based models. There's people working in big data. There's people working on emerging contaminants. There's people working with other animal models, so non-traditional species, and trying to figure out how those species are impacted either as wildlife species or as a model for human health. So I can say in my sort of corner of toxicology, I think some of the interesting things will be about some of the new emerging contaminants that are showing up based on the work of the analytical chemists. But also, and I wouldn't say that it's a new big thing because it's been a problem for a long time. It's like, how do we deal with mixtures toxicology? Like, how do you deal with the fact that generally in the lab, we'll look at a single compound and we'll figure out what the effect is of that single compound on a single organ system or an animal model. But we really don't understand how to put all of those pieces together when we know that everybody's exposed to a lot of different chemicals all at once. And how do you determine which chemicals are driving the effect that you see in a phenotype or an outcome study or either animal, clinical, or cell culture? So I think those are really the big questions that are in toxicology. I also think big data is becoming a lot more important, and machine learning, artificial intelligence, to try and understand maybe how to put together these mixtures toxicology questions. So I think if people are interested in coding and data and AI and machine learning, I think those are really going to be great opportunities for people to use those skills in the field of toxicology. That's kind of hard because some days I don't even think of myself as like a straight up toxicologist, right? I feel that I have a pretty interdisciplinary research program that includes toxicology. And I think probably the success of that is based on the fact that I have a pretty wide ranging set of interests and research questions that I'm interested in the lab. I think for me, in terms of general success in research, I think I have a pretty broad-based background. So I was trained in zoology, which is, we were thought to think about different species and a whole range of things from ecology to cell systems. So I think having that background and being able to keep my eyes open to apply what I know from all of those experiences to different questions has really been what's made me successful in obtaining funding and getting these projects through to completion. So I'd say go and have a look at what current toxicology looks like. So I think toxicology, in some people's minds, it's a very specific thing about sort of, is a drug toxic, or if you're exposed to a chemical, does it kill an organism? And I think it's so much broader than that. There's so much scope for people to apply their interest to the toxicology field. So like I said earlier, if you're interested in big data has a place in toxicology. If you're interested in developing alternative testing methods that are non-animal testing and different cell-based models like organoids or organ on a chip, those also have a place in toxicology. So if you think that you're interested in any sort of understanding how drugs or chemicals or environmental exposures may impact health or fitness or wildlife populations, go and have a look at what's going on in toxicology. I think it is so broad that it's really hard to give like a very generic piece of advice for how to get into the field. You know, it's a very welcoming community. So I think talk to people who are doing toxicology research in an area that you might be interested in. Look at the abstracts that are being presented at STC and other toxicology meetings and see if there's a space where you're super excited about what's going on, and then look at the graduate programs across the country. I actually didn't do a specific toxicology graduate degree. There are some great programs across the country, but there's also ways to get into toxicology by doing toxicology research under the auspices of a different type of research. So I think that keep your eyes open and your mind open, and you can find your lane for having a career in toxicology. So I think my biggest thing that I've really learned as I've moved on in my career is that not all students are good at every single technique, right? So it's not a one-size-fits-all mentorship. I have students who are really exceptional at the lab work, but they're not as interested in parts like the scientific communication. I mean, you want the students to be well-rounded, and we try really hard to get students to be interested and to have the basic skills at being a well-rounded scientist. But I think you also have to encourage and nurture the things that they're really good at, because that gives them success and that makes them be excited about what they're doing. And so if you can nurture those other skills that may not be traditional, like can you pipette, but you're really amazing at making videos or this knowledge translation, then nurture that, because having success and being excited about their project makes them excited about the whole of their project, more than if they're struggling with one particular aspect.